So let's have a quick recap of all the formulas we need for mensuration. First and foremost, we need the area for circle. Area of circle. The only dimension, children, we have for a circle is radius. So area is pi r squared. Perimeter is the same as circumference is 2 pi r. Semicircle. Half of a circle, children. Half of a circle. This being the radius. Area pi r squared divided by 2. Perimeter. Circumference, half of the circumference, but perimeter, children, is length of all the boundaries, so it's pi r plus 2r. Then we've got a sector, children. Sector is not on syllabus. We only have quadrant, but I'm giving it the formula for sector and specifying how to apply it for a quadrant. It's like a part of a circle, some part. That angle is theta and the radius is r. So area of sector, theta upon 360 into area of circle, that's pi r squared. Circumference is this round part, children, L. The length of the arc is theta upon 360 into 2 pi r. And children, perimeter will be length of all the boundaries. So it's the length of the arc plus the 2 radii, because that's the full length of all the boundaries, children. In case of a quadrant, children, which is what they're going to ask you, quadrant, children, theta is fixed to 90 degrees. In case of a quadrant, please remember that, children. Ring is 2 concentric circles. First one, second one. The area in between, children, is the area of a ring. If this be the center, this is capital R, this is small r. For ring, children, area is pi capital R squared minus small r squared, because it's area of big circle minus area of small circle, which we can take common and do difference of 2 squares, which will make the calculations easier for us to work with, children. And lastly, distance traveled by a wheel. Distance traveled by wheel equals to circumference into number of revolutions, children. Let's see some examples to elaborate on this, children. Question says, find the perimeter and area of a semicircular plate of radius 25 centimeters. So an example. Question says, find the perimeter and area. Find perimeter and area of a semicircular plate of radius 25 centimeters, children. So, children, semicircular plate, radius 25 centimeters. First, they've asked for the perimeter. Perimeter is pi r plus 2r. And children, here they specify take pi as 3.14 because we can cancel it off with 25 and 100. They are multiple, children. If we take this 314 upon 100, we'll cancel off with 25. We'll see how that happens. That becomes r pi plus 2. R is 25, pi plus 2 would become 5.14. That's 514 into 25 upon 100. This cancels with this. 4 times cancels with this. 1. 11 will go 2 times. 34 will go 8 times. 20 will go 5 times. 128.50 centimeters, children, would be the perimeter. And as far as the area is concerned, children, it will be pi r squared upon 2. That's 3.14 upon 2 times 100 times r squared. That's 25 times 25. So we'll cancel with this to give you 4, cancel with this to give you 157. Now children, to multiply this 157 by 25, let's multiply it by 5 quickly children. That would give us, when you multiply it by 5, so children, this simplifies to 981.25 centimeters squared. What's the next question children? Now the question says, two circles touch each other externally. So a diagram for this kind of a sum would be, the sum of their areas, take the radius to be capital R and small r. The sum of the areas 117 pi centimeter squared. Sum of areas 117 pi centimeter squared, and distance between centers and distance between centers is 15 centimeters. Find the radii of the two circles. Find the two radii. So children, the information we have is capital R plus small r is 15. So capital R is 15 minus r. That's one relation we've got. Also we know that pi r squared plus pi r squared is equal to 117 pi. Taking pi common, we get capital R squared, which is 15 minus r the whole squared, plus r squared is equal to 117 pi. Pi cancels, let's expand this children. So we get 225 minus 30r plus r squared equal to 170, or 2r squared minus 30r plus 225 minus 117 children would come out to be 108 is equal to 0. Since we can divide everything by 2, we will do that. That'll give us r squared minus 15r plus 54 is equal to 0. And children, 54 would factorize to give us 9 times 6, which are the factors. So it's r squared minus 9r minus 6r plus 54 equals to 0. Take common, so we get r minus 9 minus 6r minus 9 is equal to 0. r minus 9, r minus 9, r minus 6 is equal to 0. So we'll take r as 6 children, hence we'll get the capital R value as 9, smaller radius and bigger radius, and that will give us the radii of the two circles. Let's see next question children. An equilateral triangle is inscribed in a circle of radius 4. So there is a circle children, and there's an equilateral triangle inscribed in this circle, with the radius being given to us as 4. So children, this length, all the way this length comes out to be 4 from center to here. It's an equilateral triangle, so all sides are equal and all the angles are 60 degrees. Let's write them down first as a question. An equilateral triangle is inscribed in a circle of radius 4 centimeter. Find the area between the circle and the equilateral triangle. Enclosed between equilateral triangle and the circle. So children, for a sum like this, the angle over here comes out to be 30 degrees since the full angle is 60 degrees, and these two triangles come out to be congruent since this is common, this is right angle, and this is common, this is the right angle. And children, a line from center of circle perpendicular bisects it. So these two sides come out to be equal. So by right angle hypotenuse side as the two triangles come out to be congruent. So this comes out to be 30 and 30 degrees. Children, we can just write down that the angle. We can say that, children, that's triangle OBN congruent to triangle OBM by RHS test by showing the right angle. This is common and this part is equal to this part. Therefore, children, angle OBM is equal to 30 degrees bisected and part of 60-degree angle of an equilateral triangle, children. Since the full angle is 60 degrees, this will be 30, 30 for equilateral triangle, children. The full angle is 60, so this will be 30 and 30. Therefore, children, we need to find out the side. So I'll take the side as x by 2, children. So cos of 30, since we have adjacent and we need to find the adjacent, we have hypotenuse. It's x by 2 times 4. Cos 30, children, is root 3 by 2. So which is equal to root 3 by 2. 2 cancels, children, to give you the value of x as 4 root 3. So children, the side comes out to be 4 root 3. If the side is 4 root 3, children, the area enclosed between would be area of circle minus area of equilateral triangle. Area of circle pi r squared minus root 3 upon 4 side square, children, that's pi r squared minus root 3 upon 4 into side squared. Cancels, children. So that becomes 3.14 times 16 minus 4 times 3, that's 12 root 3. Now this, children, we have to find out the value of each thing individually, children. We have to find out the value of each individually. That's 3.14 times 16, which comes out to be 50.24 minus 12 root 3. That's 12 times 1.732, children, which comes out to be 20.7840, which we subtract, children, to give us 29.456, which would approximate the area to 29.46 centimeters square, children. That's the answer. That's the area of this region. If you want to specify the region, this is the region between the two, which is area of shaded region. This next question, children. Find the area and perimeter of a shaded region given in the figure. So the figure is given to us as a semicircle, children. Well, this line being the diameter, but the value of diameter isn't being given, but we've been given that this side measures 12 centimeters, this measures 16 centimeters, and it's been specified the center is on this line. And they want us to find out the shaded region, children. This is the shaded region. They want us to find out the value of this shaded region, children. So children, first we'll find this angle out. This angle, we'll name this as ABC. And this angle B would come out to be 90 degrees. We'll specify that first. Angle ABC is equal to 90 degrees. Angle subtended by semicircle is right angle. Next, children, we'll use Pythagoras to find out AC. That's AC squared is equal to AB squared plus BC squared, children, which is 12 squared plus 16 squared. 12 squared is 144, 16 squared is 256, which gives us 400, children. Straightforward. And the reason for this is Pythagoras. Then, children, AC correspondingly comes out to be 20 centimeters, which means the diameter is 20. Again, children, we have to specify, take the value of pi as 3.14. That's ease of calculation, children. That's for ease of calculation. So the radius comes out to be 10 centimeters. Since AC is diameter, radius comes out to be 10 centimeters. Now children, area of shaded is equal to area of semicircle minus area of triangle, right angle triangle. Area of semicircle is pi r squared upon 2 minus area of triangle, which is half, into product of perpendicular sides or base into height. Well, we can take one of them as base, the other one as height, or vice versa. So that's 314 upon 100 into r squared upon 2 minus half times base times height. Cancels with this cancels with this cancels, just give you 157. So it's 157 minus 12 times 8, that's 96. Difference, children, comes out to be 61 centimeters squared. That's the area. For perimeter, children, perimeter would be this length plus this length plus this length. Children, perimeter is always the length of all the boundaries. Length of all the boundaries, children. So the boundary for the shaded region is this round part plus this part plus this part, children. So be careful with that. So perimeter would come out to be circumference of semicircle plus AB plus BC. That's pi r, children. That's 3.14 or 314 upon 100 into r. That's 10 plus 12 plus 16. This cancels with this to give us 31.4 plus 28. When we add it, children, we get 59.40 centimeters. That's the perimeter of this figure, children. Let's see next question. Now, children, we'll see a few formulae for mensuration. First, for cylinder. The formulas we have for cylinder. All the dimensions we have for cylinder, children. A cylinder is a figure which looks somewhat like this. Circle at the bottom, circle at the top. It's uniform, children. It's uniform. It's the same thing from top to bottom. This becomes R. This is the height. One by one, children, the area. The volume first. Volume is area of circle times height. Curved surface area. The round part, this is the circumference. It's 2 pi r h times 2 pi r h times curved surface area, and total surface area. The round part plus the two circles. You can take common, children, simplify, that's up to you, depending upon the question. For a pipe, children, for a pipe, the formulae are this is a ring, children, over here, and it's capital R, this is small r, this is height still. So volume, children, comes out to be area of cross section, which is pi r squared minus r squared, that's for a ring, times height. The total surface area, children, total surface area now comes out to be the outer surface plus the inner surface plus twice the area of ring. Let's see some sums based on this, children. A question says, a closed rectangular box of dimensions 40 centimeters by 30 centimeters by 25 has same volume as that of a cylindrical tin of diameter 35 centimeter. Calculate height of 10. 1 decimal place. Correct to 1 decimal place. Take pi as 3.14. Now children, they've specified the value of pi, so we have to consider that. So children, what we have over here is volume of rectangular box is equal to volume of cylinder. So children, volume of box is length times breadth times height. Volume of cylinder is pi r squared h. This is pi r squared h. And box is length into breadth into height, any which ways children. And this would come out to be 314 upon 100 into r. That's 35 by 2 into 35 by 2 pi r squared. H comes out to be the unknown children, the variable. Now here children, what we can cancel is and that's it children, nothing else cancels. So you're left with a value of, that's 12 times 25. So children, this simplifies to 40 times 30 times 25 times 8 upon 157 times 49 children. There's no other option but to multiply and divide, which will all simplify to 31.1972. Till 1 decimal place children, it will simplify to 31.2 centimeters as the height children. Let's next question children. Find the volume of largest cylinder formed. Find the volume of the largest cylinder formed in a rectangular piece of paper (33 centimeters by 16 centimeters) is rolled along its longer side. Is rolled along its longer side. So children, there is this rectangular sheet of paper whose dimensions are 33 by 16. Now it's rolled. It's made into a paper roll like that. It's rolled. And then they want us to find out the volume of this cylinder children. The relation it has is this length is the same as this. That means circumference of this is equal to this. And the height is the same as this. So height comes out to be 16. The height comes out to be 16. The circumference of this is equal to this. So circumference, which is 2 pi r, is equal to 33. That's 2 times 32 by 7 times r is equal to 33. This cancels with this 3 times and 2 times. You're left with r is equal to 21 by 4, which is 5.25. If it works, we'd rather work with a fraction children. Fractions better and faster to work with. Now the volume would come out to be pi r squared h. That's 22 by 7 times r squared h. Well, this cancels with this cancels with this. You're left with 22 times 21 times 3. That's 22 times 63, which is 1386 centimeters cube. That's the volume children. Let's see the next part. Next thing children we have is cone. In case of a cone children, the formulae we have for cones, the volume is a third of a cylinder. The volume is a third of a cylinder. This is the radius. This is the height. This is slant height children. And the relation we have for that is L squared is equal to H squared by R squared. Simple Pythagoras theorem. Volume is a third of a cylinder of the same radius and same height. Curved surface area children is pi RL. and total surface area, children, accordingly would come out to be the curved part plus the bottom, which you can take pi r common and simplify. Now children, let's take an example to elaborate on this. Question says the total surface area of a right circular cone of slant height 20 centimeters is 384 pi centimeter square, children. Pi is given for ease of calculation. Pi is given for ease of calculation. Calculate its radius and volume in terms of pi. So here, children, the calculation becomes easier because you leave the volume in terms of pi, you don't have to calculate it beyond that. So the diagram would be something like this. The cone where the radius and the height is not known to us. Height is not known, radius is not known, but slant height is known to us as 20 centimeters and the total surface area is given to us as 384 pi. So children, total surface area, remember write down full forms, no short forms allowed. Remember write down full forms, children. Do not use any short form unless you write down as total surface area and then write down TSA and then work forward with it. So that's pi r L plus r taken common. So that gives us, children, the curve surface area is, the area is 384 pi is equal to pi times r times L, which is 20 plus r. Now pi cancels, open the bracket up, you get r squared plus 20r minus 384 is equal to 0. Now children, we'll solve this product and sum trinomial. The factors of 384, children, the factors of 384 will come out to be, children, the factors for 384 would come out to be plus 32r minus 12r minus 384 is equal to 0. We take common, r taken common, r plus 32 minus 12 taken common, r plus 32 is equal to 0. That gives us r minus 12 or r plus 32 is equal to 0. That gives us r is equal to 12 or r is equal to negative 32, which is not possible, children. Radius can't be negative, so it's r is equal to 32. Now the volume, children, the second part, volume. The volume, children, is 1/3 pi r squared h. So volume is equal to pi upon 3 r squared h, which is pi upon 3 into r squared into h. Now children, if this is 12, this is 20, by Pythagoras theorem, we'll get h squared is equal to L squared minus r squared. That gives us L minus r, L plus r. That's 20 minus 12, difference of two squares, 20 plus 12. 20 plus 12, children, comes out to be 32 and 20 minus 12 comes out to be 8. We divide this one, we multiply this one by 2 and we divide this by 2. So h simply comes out to be 16 centimeters, children. So that's 16 over here. This cancels with this to give you 4. So your answer 16 times 4, that's 64 times 12. 64 times 12, children, comes out to be 768 pi centimeter cube, children. That's the volume in terms of pi. The answer is to be left in terms of pi. That's what they've asked us for, children. Let's see another part. Children, for a sphere has only one dimension like a circle. The difference is it's three-dimensional. So children, for a sphere, we've got volume, which is 4 upon 3 pi r cube. Curved surface area or total surface area is 4 pi r squared. For a hemisphere, volume is 2/3 pi r cube. Curved surface area would be the flat part, which would be half of this. The curved part, sorry, which will be half of this. So 2 pi r squared will total surface area, children, would come out to be 3 pi r squared. Then, children, we have a hollow sphere, dimensions being capital R and small r for the same. Capital R and small r. Hollow sphere volume 4/3 pi r cube minus r cube. Curved surface area or total surface area is 4 pi r squared plus r squared. And then, children, there is something like a bowl which is hollow hemisphere. The dimension it has is capital R and small r again. So that's hollow hemisphere. Volume 2/3 pi r cube minus r cube. Total surface area, children, would be, total surface area, children, on simplification comes out to be pi times 3r squared plus r squared. It's total surface area. Now let's see an example. Let's see some examples based on this, children. A question says the curved surface area of a sphere is 2826 centimeters squared. The curved surface area of a sphere is 2826 centimeters squared. Calculate its radius and hence its volume, taking pi. Calculate its radius and volume. Given pi is 3.14. So, children, curved surface area of a sphere is 4 curved surface area of a sphere is 4 pi r squared, which is given to us as 2826. So that, children, 4 times 314 upon 100 into r squared is equal to 2826. So that gives you the value of r squared, children, as it simplifies to, children, give us 225. So, children, r accordingly comes out to be 15 centimeters. 15 centimeters, children. That's radius. So now, children, the volume is 4 upon 3 pi r cube. That's 4 upon 3 into 314 upon 100 into r cube. This will cancel with this, children. 5 times will cancel with this. This will cancel with this. And, children, finally this will cancel with this. So your answer is 45 times 314, which simplifies to, children, 14,130 centimeters cube. That's the volume of this sphere, children. Let's see some more examples on this. Question says, how many billets each of radius 3 upon 4 centimeters can be made by melting a cylinder having radius 5 centimeters and height 18 centimeters. Now, children, here what we have is number of spheres into volume of each sphere is equal to volume of cylinder. So, children, we can bring the volume of cylinder down. So that's number of spheres comes out to be pi r squared h upon 4 upon 3 pi r cube. Pi cancel, children, the 3 can come up. So that's 3 times r squared h upon 4, and the 3 has gone up. So that's r cube, that's 3 times 3 times 3, and the 4 come up. 4 and 4 cancels, 3 and 3 cancels, 9 cancels with this 2 times. So that's, children, 10 times 20, that's 200 times 4, 800. So 800 spheres can be, or bullets can be made, each of radius 3 by 4 centimeters out of the cylinder. Let's see next example, children. Question says, a cylinder, a hemisphere, and a cone have equal base diameters and same height. Find the ratio of their volumes. So, children, a cylinder, a hemisphere, and a cone, they have the same base radius. So it's r here, and r here, and height is the same, children, but the height over here for this is r. The height for this is r. So this will also come out to be, children, r accordingly, and this height will also come out to be r. So now, children, writing down the formulae for each, for cylinder, hemisphere, and cone. Cylinder is pi r squared h. Hemisphere is 2 upon 3 pi r cube. Cone is pi upon 3 r squared h. And, children, h is equal to r. First we'll cancel all the pi's, multiply everything by 3. So we get 3 times r squared r is to 2 times r cube is to r squared r. So, children, all the r cubes again will cancel out over here to give us a ratio of 3:2:1. And that's the ratio of the volumes of all these figures. With this, we end our crash course on mensuration. Thank you.